So before we move on, we're going to know first the parts in the radical. This is the index. It can be 3, which means cube root, 4 for fourth root, and so on. If there are no written index, that means it is a square root. It tells what root is being taken. And inside the radical sign is the base or the radicand. It can be either a number or a variable. It is the value you want to take the root of. Next is the exponent. It tells how many times the radicand will be multiplied to itself. Sometimes there is a coefficient. It is the value that don't need to find its root, but can multiply to other number outside the radical sign. Next up is an important rule. When multiplying radicals, the index of each radicals must be the same. For example, if the other radical has a cube index or is a cube root, the other must be in cube root too. And if the other is a square root, the other radical to be multiplied must be also square root, and so on. So let's start with the basic. So what you are going to do first in this given is to multiply the radicands, which is 18 and 2. We got a product of square root of 36. If the product can be rooted by the index, then simplify it. 36 has square root, so we're going to simplify it. It is equals to 6 because 6 squared is equals to 36. I'm going to show you another method which you can use and also has the same answer as the first one. It is just your choice what method you will use. But what if it has coefficient? If there is a coefficient or a whole number outside the radical sign, then multiply it. So in this, we multiplied both radical and coefficient, then find its factor. So 4 has a square root, which is 2. Then bring it outside the radical sign. Then multiply it with the coefficients, which results to 12. Well, square root of 3 has no root, then just leave it in the radical sign. But what if it has variables and exponents? When multiplying radicals with exponents, add the exponents. So first, let us multiply the radicands. 8 times 2 is equals to 16. And since we are multiplying with exponents, we are adding the exponents. So, first we add x squared times x is equals to x cubed. X as an exponent equals to 1. Then, next is y times y to the fourth power is equals to y to the fifth power. It is a rule that you only perform operation with like terms. Then, let's simplify it. 16 as a square root is equals to 4. Then, let us find the factors of x cubed and y to the fifth power. Because we are adding exponent, we need to find factors with exponent that when added will result to the same exponent that we are finding factor and must be higher. So in this, we have x squared times x and to the fourth power times y. That if the exponent is an even number, then it is a perfect square. And if the exponent is an odd number, then it is not. So next, let's find the root of the variables inside the radical sign. X squared has a square root, which is x, because x times x is equals to x squared. Then we bring it outside the radical sign. X has no root, so just leave it inside. y to the fourth power has a square root of y squared. Then move it outside. Y has no roots, so just leave it inside the radical sac. If there are none left to simplify, then that is the answer. Okay, before we get on, first let us know the conversion of the base with an exponent of fraction into radical form, and vice versa. So, the base or radicand is also the base of the exponent, which you can see is represented by x. The denominator is the index, which is represented by b, wherein the index can't be 0. The numerator is the exponent, which is represented by a. Okay, let's move on. What if the given has different index? Well, the rule says that to multiply radicals, the index must be the same. We're going to convert radicals into whole number with fraction, similar to what conversion we did in rationalizing exponents. And then after that, find the LCD of the denominator. We will find that by finding each denominator's multiples and find the lowest multiple that they have the same. So in this, they have both 4 as LCD. Then divide the LCD to the denominator of the given. So 4 divided by 2 is equals to 2. Then multiply 2 with the numerator of the given. Next is to divide the other radical. 4 divided by 4 is equals to 1. Then multiply it to the numerator, which is 1. 1 times 1 is equals to 1. What we are doing is just like adding fractions with unlike denominator lesson. Then, let us now convert it to radical. When we have converted it, perform the exponent. So 3 has an exponent of 2, so we are going to multiply 3 with itself, which is equal to 9. The other radical has an exponent of 1, so no need to perform it. Next is to multiply the radicands. So 9 times 3 is equals to 27. Since the product has no root as the index, so just leave it. So that's the answer. I have another example, but you can pause the video and try to answer it.